Hello and welcome. Today we are going to talk about Newton's law of viscosity. Now consider a flow that is happening over here. Okay, and consider this as a base. It may be a pipe base or maybe simply maybe a flow. Okay, so this flow is obstructing the down layer and not the top layer. Okay, top layer is free to move. There is no wall over here. Okay, so don't you think the top layer will have the same velocity as it came before entering? So this is the driving force and it will be the same velocity, but at the bottom wall or base or pipe base, inertial as well as cohesive force of attraction of the molecules would be acting, and that would be opposite to the driving force. Okay, now inertial force is also called as frictional force. Frictional force would be acting, right? This molecule would be obstructed by the base, so that's the frictional force. That's nothing but the inertial force. Also the cohesive forces of attraction between the molecules, that is above layers, there will be a attraction between them, right? So it won't be make it to move in forward, instead it will pull it back. So now if we draw a distribution curve over here, so at the topmost layer we get the same velocity as the velocity of the flow entered, that is the driving force. But at the bottom layer, the inertial plus cohesive force of attraction opposes the driving force, it nullifies it completely. So we get the velocity over here as 0. Now consider any layer in between these two, suppose this layer. Over here the inertial plus cohesive forces of attraction are less than the driving force, a little bit less than the driving force. So resultant force in the direction of the driving force. So we get a little driving force in the forward direction. Similarly over here, as we move away from the base, the driving force would be little more than, will be more. Actually, I mean to say that inertial plus cohesive force would be little less, more less as we go up. So the driving force would increase, as the resultant force would be more in the driving direction. So as we grow from this to this point, we get this line complete. Okay, so now let me analyze this diagram over here. Okay, now at this layer, let's consider the velocity at this layer be u plus du, and at this layer be u, that is it's little less than this layer, and the distance of this layer from the datum be y plus dy, and the distance of this layer from the datum be y. Now don't you think so this layer will force this layer to come up to its speed? It will force this layer to tell, bro, why don't you come to my speed? Now in turn this layer would say, friend, why don't instead you move at my speed? So this leads to the shear stress between them. A concept of shear stress comes into picture. Due to this, they both exert shear stress on each other, forcing them to move to its speed. So now that shear stress is denoted by tau, and that is proportional to difference in the speed between them. We can see the difference in the speed between them would be du, divided by the distance between the two layers, that would be y plus dy minus y, that will give us dy. Now this would be equal to this equation, and this term we got is nothing but coefficient of dynamic viscosity. Okay, this is nothing but the Newton's law of viscosity. Now let's talk about the unit of the coefficient of the dynamic viscosity. Separating this, we get tau divided by du by dy. Now, and we can write it in terms of units as shear stress can be given as unit of shear stress as Newton per meter square. Now this is velocity. So velocity is meter per second, and this is nothing but distance between the two layers, right? So it's nothing but meter. Now we cancel this. What we get is Newton second per meter square. Now in CGS system, we get dyne second per centimeter square. We call this as poise. 1 poise. This is equal to 1 poise. Now relationship between these two is nothing can be given as Newton second per meter square is equals to 10 poise. That is 10 dyne second per centimeter square. Now the relationship between poise and centipoise is the same as the relationship between meter and centimeter. So if considering this as meter, if we want to convert it into centimeter, you would say 10 into 10 raised to 2 centipoise. That is nothing but 10 raised to 3 centipoise. This is the relation. Remember this. Thank you.